Hey guys, welcome back to another video. Today, we're going to be deriving what Richard Feynman described as the crown jewel of mathematics, also known as Euler's identity. A key concept, and it's spelled Euler, but it's actually Euler. Euler's identity. And what makes this identity so beautiful, and we'll see this in a little bit, is that it combines all the greatest parts of mathematics. It's going to combine 0, 1, E, Euler's number, I, the imaginary number, and 0. So, yeah. And also, it's the key for understanding polar complex numbers, which is fundamental in the sum of the reciprocal of squares, which is 1 over n to the 1 over n squared, which ends up being pi squared over 6. Okay, anyway, let's start. So, the first step in doing this proof is the power series of e. We know that the power series of e to the x is equal to x to the n over n factorial. Therefore, starting at n equals 0, we're going to have x to the 0th power, that's just 1 over 0 factorial. Plus, now we'll have x over 1 factorial when n equals 1, so on, so forth, plus da-da-da-da. Now, what Euler thought is, okay, what if I plug in e to the ix now into the series? And remember, if you may be asking yourself, how do we do this? Well, we can just take this and plug this in every time we see x, right? So it's just a direct substitution. So, therefore, e to the ix is equal to 1, because there's no x's there, we can't plug anything in, plus ix over 1 factorial, plus, and we're going to go out to the 4th for this. Okay, ix squared over 2 factorial plus ix cubed over 3 factorial plus ix to the 4th over 4 factorial. Okay? So, now, what's going to be really important here is that we know our i's. Okay? So, we need to know that I is equal to the square root of negative 1. I squared is thus equal to negative 1, just because if we squared this. Then we know that I cubed is equal to negative I, and we know that I to the 4th is just equal to 1. Okay? So, now doing this here, we can see that now, by just simplifying, essentially, so we have 1, because 0 factorial is 1, remember that, we're enough plus ix over 1 factorial. Now we see ix squared over 2 factorial. Remember, I squared is negative 1. So we're going to have minus x squared over 2 factorial. Okay. Now we have plus. Okay. What's I cubed? I cubed is negative I. So now we're going to have minus ix cubed over 3 factorial. And now we're going to have I to the 4th, which is just plus ix to the 4th over 4 factorial. Okay? Now, what Euler thought next, and we could say that ix is equal to I theta. That's really the correct way to do it, but I messed up, so it's chill. Now, what we're going to do is Euler said we're going to divide this into the real parts and the imaginary parts. This being a real part, this being a real part, this being a real part. It's basically all the parts where we don't have an I, okay? So that would leave us now with 1. So this we'll call the real part. We're going to have 1 minus x squared over 2 factorial. Over 2 factorial. This is, yeah. Minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And so, as you might note here, this is just the power series of cosine. Because remember that the power series of cosine is just 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial plus so on and so forth of x to the 2n over 2n factorial. And then you have a negative 1 to the n, which is going to be your oscillator. However, okay, so now we know that this real part is equal to cosine. Okay, so we got that. Now we know that our imaginary part, which is this, or anytime we see I, now we're going to know that that's going to be imaginary, is going to be, we're going to factor out an I in this case, because all our terms will contain I. We're going to have x over 1 factorial, which is just x. Then we're going to have minus x cubed over 3 factorial. And then we'd have a plus x to the 5th over 5 factorial if we were to continue. And now what we notice is, wow, this is just the power series of sine. Because I'll remind you all that sine x is just equal to x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus blah, 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 blah. So now we can see that if we just multiplied this whole thing by an I, we have this. So now restating this, I'm going to erase this up here. Now we know that e to the ix is equal to a real part, cosine x, and an imaginary part, I sine x. So now I'll write it up here. E to the ix is equal to cosine x, our real part, plus I sine x, our imaginary part. And this is where things get interesting. Now, if we say, let's plug in, and this is a angle measurement x there. If we say, let's plug in pi, e to the I pi is equal to cosine of pi plus I sine pi. And to all my viewers who might say, how do we know what sine of pi is without a calculator? And I'm going to show you. If we created a circle, and we're going to call this the unit circle. Actually, let me draw the circle a little better. If we create the unit circle, this is a circle with radius 1, diameter 2, and it's going to be broken up into these 3 angles here. Okay? This being pi over 6, pi over 4, pi over 3. A reiteration of that to here, where this is pi over 2, this is 3 pi over 2, and this is 0, 2 pi, 4 pi, etc. Now, we can say that cosine is simply the x value at this point. At this point here, we can see that we've moved over -1 units from our origin. We know this because that's our radius. Therefore, cosine of pi is equal to -1. Now let's do the same thing with sine. Sine is just the y value. Sine equals y, cosine equals x, okay? So, the sine value of this is 0 because we aren't going up any units. We're just sitting here. We're just here, right? We haven't gone up at all. We're just stationary. So, we know that sine pi is equal to 0. Now, with our newfound knowledge of the unit circle, we're going to say now e to the I pi is equal to cosine theta, -1, plus I sine theta, which is 0. Therefore, e to the I theta plus 1 is equal to 0. And a continuation of this is if we say let's multiply Euler's identity by a real number r, we thus get r e to the ix equals r cosine x. We'll actually use theta here to be correct, plus r I sine theta. Now, this is equal to z equals a plus bi. We have thus created a polar complex, the crown jewel of mathematics, 0. The number where anything you multiply it by, you get 0. It's the base number. It's the discovery of the ancient minds, and it's phenomenal. 1. The property where anything you multiply by itself is just 1. Anything divided by itself is also 1. E, Euler's number, the inverse to the natural log. I, the square root of -1. And pi, the number we need to find the circumference and area of a circle.